Good morning, guys. Welcome to the second to last Monday of the first semester. We are almost halfway through the school year. Crazy, crazy stuff. One more week, and then it's a 3-day vacation. But a lot to get through this week. We're going to do 4 sections of Chapter 6, brand new stuff. Stuff that I think you'll find a little bit laid back. The algebra was tough stuff. Now we're going to be kind of getting into some different things, ratios, proportions, and fractions, things that may seem a little bit more familiar and a little bit better to understand. So getting started today, I am on page 267, so it may be helpful for you to take some notes while you go along, so that you could be successful in your math problems. So we're talking about ratios. And ratios are actually very similar to fractions. They can be written as fractions, but they also have different forms. So often we see ratios written as a sentence, which is what you see up here on the screen. But sometimes they could be written like this. And that's simply saying 12 to 18. That's what that colon means. Or sometimes you'd see, 12, actually it written 12 to 18. Okay, that's a 12. Bad handwriting and then a really crappy smartboard that doesn't really work all that well. But we're going to be actually writing it as a fraction. And not just, well, we got to do some simplifying too. So here's our example. We have 12 baskets in 18 attempts. So maybe this is a class, they're doing basket weaving, and only 12 people got completed baskets out of 18 people that tried. 18 attempts. So we're going to be working on writing this as a fraction. So simply, we just start out with writing 12 over 18. Basic as that. But can we stop there? Not quite. We can simplify. Both of them can be divided down by a common multiple. So a common multiple of 12 and 18, let's see, 3, yeah, 3. 18 can be divided by 3. They both can be divided by 2, but I'm trying to think of higher numbers. I was thinking 4, but, 6. There we go, that's the best. 6, both can be divided by 6. So we're going to divide both by 6. And so if you wanted to rewrite it all out, you can see that on the book, but I'll just do the simple thing. 12 divided by 6 is 2, and 18 divided by 6 is 3. And this is our completed answer, 2/3. So it says the ratio of baskets to shots. Oh, they're talking about basketball, not basket weaving. Silly me. But the ratio of baskets to shots attempted is 2 to 3. So this means that for every 3 shots attempted, 2 were made. Also, 2/3 of the shots attempted were baskets. So I wish I had this good of a ratio. This is actually, for real NBA players, this is pretty good. 2/3, that's not too bad. That's why they get paid the big bucks. But, as you can see, you throw me out on the court, not really going to happen. It's definitely not 2 out of 3. So I can't believe I said basket weaving and not basketball. Okay, but that's the idea, is they give you a number, the sentence, first write it as a fraction, and then we simplify it. And it's trying to show the idea that 2 out of 3 shots are a basket. The 1/3, the leftover, are misses, so they get off the rim, air ball, all that kind of stuff. All right, let's go on to the next page. Turn the page. Let's do a real-world example, because basket weaving isn't one. So I'm at the top of the page, and it says 10 out of every 30 Americans owns a portable MP3 player. So we've got 10 over 13. 13? 30. Man. I am off my game. 10 out of 30. 10 over 30. So that's a real life statistic. I bet you it's higher. If we, out of the class, if we included iPads, or other tablets. Most people have a tablet or MP3 player. But let's simplify this down. So both, what do you think? What's our highest multiple that both have in common? Well, probably 10. So both can be divided by 10. So we've got 10 divided by 10, which is 1. 30 divided by 10 is 3. So we could reduce that down, and we could say 1 out of 3 Americans owns a MP3 player, portable device. So that sounds a little bit better rather than 10 out of 30. It's just simplifying it down, breaking it down. All right. Now let's go to measurements. So this is going to be something new for you, maybe, or something that could be a little bit sense. But we have measurements that we can break them down and figure out what it is. So let's look at the page. So our example is, it says, express the ratio 8 ounces to 3 pounds as a fraction in simplest form. So we have 8 ounces, so they're talking about weight, to 3 pounds. So our symbols would be, we have 8 ounces, so OZ, that's a Z, not a really good Z, and we have 3 pounds, so LBS is the symbol for pounds. So we can write this as our fraction, 8 over 3, but is that equal? Do you guys know how much an ounce is compared to 1 pound? An ounce is it's a smaller unit of measuring weight than a pound. So we have to figure out how many ounces are in a pound. So we're actually going to change our pounds to ounces. So when we're talking about weight, if you look at the page, it says we have to convert 3 pounds to ounces. And we know that in every pound there is, let's see, I'm checking the back of my book. The very last page tells me that 1 pound equals 16 ounces. So we need to change, because right here, if we wrote our symbols, they don't add up. We need to make them the same. So we're changing it to ounces. So we still have 8 ounces, but we got to figure out how many ounces 3 pounds. So we know that 1 pound equals 16 ounces, so we're going to do 3 times 16, which gets us, let's see, that would be 48. 48 ounces. So we're just finding a common measurement. Thinking like, maybe it helps you to think of inches and feet. You know that there's 12 inches in 1 foot. Well, this is just a different kind of measurement. So that's supposed to be an 8. So we have 48 ounces. Now we can simplify this. Does 8 go into 48? Yes. How many times? 6 times. So we're going to divide both by 8. And that's a 1. And that's 6. So we could say that our simplest is 1 ounce. 1 ounce is, 1 ounce to 6 ounce. That would be our breaking it down from this. 1/6 is 1 to 6. That's our ratio. It's 1 to 6. All right, and let's do the guided practice. And then I'll let you go, because this can be kind of confusing. So we have express the ratio 15 inches to 1 foot as a fraction. So we got 15 inches to 1 foot. Okay, so we'll start out with our 15 over 1, but we need to make our units the same. So like I said earlier, I guess I just knew this was coming up. We're going to keep our 15 inches and we're going to change our feet to inches. So 1 foot equals 12 inches. So we're going to put 12 inches on the bottom. And what's the highest number that both can be divided by? Looks like 3. So 15 divided by 3 is 5 inches. And 12 is 4. So we end up with 5. Our ratio is 5 inches to 4 inches. And this really just kind of the way that we would really use this is it just makes more sense. It's more accurate. Because when you look at 15 to 1, it doesn't really add up. It kind of seems like, well, 15 is a lot bigger than 1 foot. But when we change 1 foot into inches, then we really see, oh, it's just 5 to 4. There's not that big of a difference. So we're really just kind of making it more simple, a little bit more understandable, and really it's just getting these same units. We want to make sure that we have the same units that gives us accurate, important information. So this would actually be really big on thinking about the house that's being built. Measurements are huge. That could really make or break a house. If you get measurements wrong, if you, for example, if you kind of mess up your conversion between inches and feet, that could really change things. If you talk about half a foot and you accidentally measure 7 inches, that's not accurate. So that's kind of the real world application. I see I hit 12 minutes. Go ahead and get started on your assignment. It's up on the board. Ask for help if you need it, and take care. I'll see you in real life.